History books often talk about the superstars, the people who make big discoveries. These are the names that become synonymous with progress and innovation, the individuals who push the boundaries of what we know and understand. They are celebrated, their stories told and retold, their achievements etched into the annals of history. But what about the teachers who help them along the way? The mentors who guide these brilliant minds, providing the foundation upon which they build their groundbreaking work. These unsung heroes often remain in the shadows, their contributions overlooked. Isaac Barrow was one of those teachers, a super smart guy himself, who helped his most famous student, Isaac Newton. Barrow was a mathematician, a theologian, and a scholar of immense talent. His own work laid the groundwork for many of the scientific advancements that followed. This video is all about Isaac Barrow, a hidden hero of science. We'll delve into his life, exploring the various facets of his career and the impact he had on the scientific community. From his early years to his time at Cambridge University, Barrow's story is one of dedication and brilliance. We'll look at his awesome work in math, how he studied light, and how his innovative ideas paved the way for future discoveries. Barrow's contributions to mathematics were significant, and his work on the properties of light was groundbreaking, and how he was a super important teacher at Cambridge University. Barrow's role as a professor was crucial, and his influence extended far beyond the classroom. He was a mentor to many, inspiring a generation of scholars and scientists. Most importantly, we'll see how he helped a young Isaac Newton, whose amazing work might not have happened without Barrow's help. Newton himself acknowledged the profound impact Barrow had on his development as a scientist. Their relationship was one of mutual respect and intellectual collaboration. Even though he wasn't as famous as Newton, Barrow's work is still important to science today. His contributions continue to be relevant, and his legacy lives on through the countless students and scholars he influenced. He helped change how we understand the universe. Barrow's insights and discoveries were instrumental in shaping our modern understanding of the natural world. His work laid the foundation for many of these scientific principles we take for granted today. As we explore the life and legacy of Isaac Barrow, we'll uncover the story of a man whose intellect and passion for knowledge left an indelible mark on the world of science. His dedication to teaching and his relentless pursuit of understanding continue to inspire us. Join us as we celebrate the man behind the genius, the teacher who shaped one of the greatest minds in history. Isaac Barrow's story is a testament to the power of mentorship and the enduring impact of education. Through his work and his students, Barrow's influence continues to be felt. His story reminds us that behind every great discovery, there is often a great teacher. Let's honor the legacy of Isaac Barrow, a true pioneer in the world of science and education. Isaac Barrow's story started in London in 1630. Born into a bustling city, Isaac was surrounded by the vibrant life of 17th century London. The city was a melting pot of ideas, commerce and culture, which would later influence his intellectual pursuits. His dad sold linen and saw how smart his son was, recognizing Isaac's potential early on. The linen shop was more than just a business. It was a place where young Isaac observed the intricacies of trade and human interaction. So he made sure Isaac got a good education. Education in the 17th century was a privilege, and Isaac's father was determined to provide the best for his son. This decision would set the foundation for Isaac's future achievements. Young Isaac went to a tough school called Charterhouse, known for its rigorous curriculum and strict discipline. It was here that Isaac's love for learning began to flourish, despite the challenges he faced, where he learned to love learning. The environment at Charterhouse was demanding, but it instilled in Isaac a deep appreciation for knowledge and intellectual growth. He spent countless hours immersed in books, exploring various subjects. Then he went to Trinity College in Cambridge, one of the most prestigious universities of the time. The transition to university life was a significant step for Isaac, opening up new avenues for academic exploration. At first, he wanted to be a doctor, drawn to the mysteries of the human body and the promise of medical science. However, his true passion lay elsewhere, but he really loved math. Mathematics captivated Isaac's mind like nothing else. The logical structure and the challenge of solving complex problems were irresistible to him. He did great in school, earning his degrees with distinction. His academic excellence was recognized by his peers and mentors, paving the way for a promising career, and even got a special job at Trinity College, where he was appointed as a professor. This role was not just a job, but a testament to his intellectual capabilities and dedication to his field, showing how smart everyone thought he was. His appointment was a significant honor, reflecting the high regard in which he was held by the academic community. Barrow loved to learn new things, constantly seeking out new knowledge and understanding. His curiosity knew no bounds, and he was always eager to delve into new subjects. So he traveled all over Europe and the Middle East, embarking on journeys that would broaden his horizons. These travels were not just physical but intellectual, exposing him to a wealth of new ideas and perspectives. He learned about different ideas and cultures, which enriched his understanding of the world. The exchange of knowledge with scholars from different backgrounds was invaluable to his intellectual growth, which made him even smarter. Each new experience and piece of knowledge added to his already vast intellect, making him one of the most learned men of his time. Isaac Barrow's biggest contribution to math was getting it ready for something called calculus. Born in 1630, Barrow was a brilliant mathematician and theologian who laid the groundwork for future mathematical discoveries. His work was pivotal in the transition from classical geometry to the more advanced concepts of calculus. Barrow's innovative thinking and meticulous research set the stage for the revolutionary ideas that would follow. He looked at how lines touch curves, a concept known as tangency. This was a crucial step in understanding the behavior of curves and their properties. By examining the points where a line just touches a curve without crossing it, Barrow was able to develop early ideas about derivatives, which are fundamental in calculus, and the space under those curves, which is super important in calculus. This area, known as the integral, helps in calculating the total accumulation of quantities such as distance, area, and volume. Barrow's insights into these areas were groundbreaking and provided a new way to approach mathematical problems. In his important book, published in 1670, Barrow explored curves and how lines touch them. This book, titled Lectiones Mathematicae, was a collection of his lectures and contained many of his significant findings. It was through these lectures that Barrow communicated his ideas to his students, including the famous Isaac Newton. He figured out how to measure these lines, which helps us understand how things change instantly. This concept of instantaneous change is at the heart of differential calculus. By understanding how a quantity changes at a specific point, mathematicians can predict and analyze the behavior of dynamic systems. This is a big part of calculus. Barrow's work on tangents and areas under curves laid the foundation for the development of the fundamental theorem of calculus, which links the concept of differentiation and integration. This theorem is one of the cornerstones of modern mathematics. Barrow also looked at how to measure the area under curves. This was a significant advancement because it allowed mathematicians to calculate the total accumulation of quantities over a given interval. This concept is widely used in various fields, including physics, engineering, and economics. He saw how this was connected to the lines touching the curves, which is a really important idea in calculus. By linking the concepts of tangents and areas, Barrow provided a unified approach to understanding curves and their properties. This connection is essential for solving complex mathematical problems and has numerous practical applications. Barrow used shapes to figure this out, which helped Newton and Leibniz use numbers to do it later. His geometric approach to calculus was instrumental in the development of the subject. By visualizing mathematical concepts through shapes and diagrams, Barrow made it easier for future mathematicians to build on his work. This paved the way for the analytical methods used by Newton and Leibniz, who are credited with the formal development of calculus. Barrow wasn't just good at math, he also loved learning about light. His book on optics, published in 1669, explored how light works and how it helps us see. Barrow studied how light bounces off things, bends when it goes through things, and how lenses work. This helped people make better telescopes and microscopes. His careful studies of light rays made it possible to build better tools for seeing things, which is super important for science. Barrow really helped us understand light better. In 1662, Barrow got a really important teaching job at Cambridge. It was a brand new job meant to help people learn math and science. One of his students was Isaac Newton, who was super smart. Barrow saw how smart Newton was and helped him learn. They became good friends and talked about math all the time. Barrow shared his ideas with Newton, which helped Newton with his own amazing work. Then Barrow did something amazing. He quit his important job so Newton could have it. That shows how much he wanted to help the next generation of scientists.